All right, this is Module 25, Explore Solids. A few things of vocabulary that we need to go through beforehand is what a polyhedron is. Because we're going to be getting into three-dimensional spaces, which is, in the previous modules, we were just limited to a flat surface. Now we're going to be going into a third dimension, which adds thickness to bring it into our real-world space. So polyhedron, it's a solid bounded by polygons, poly. We call the polygons are called the faces within the figure, and they enclose a single region of space. So polyhedron is kind of the generic term, and there are going to be more specific terms and names of these polyhedron. But to take from this, faces. So those are your faces. We have another part that's called your edge. The edges are the lines that occur within the polyhedron. So we have multiple different edges here. We have an edge here, we have an edge here, we have an edge here. They're basically all over the place within this figure. And the last thing is where the edges come to a point. We call that the vertex. So those are basically each one of the angles that are created. Think of an angle in a previous module that we did. The angles that are created, the points that the actual edges come to, those are called your vertices or your vertex, singular. So polyhedrons, what are polyhedrons in terms of like picture form? Again, they're polygons. So a prism is a type of polyhedron. A pyramid, it's a type of polyhedron. What are not polyhedrons are things that have curves, like cylinders or cones and spheres. Okay, so we have identify and name the polyhedron. So it says tell whether the solid is a polyhedron, and if it is, name the polyhedron and find the number of faces, vertices, and edges. So the first thing we have to do is to name it. And anytime you have a figure like an A, we have a figure that is basically bounded by rectangles or squares. We call that a prism. And it's based off of the bottom portion of it. So since the bottom portion is a rectangle, we call that a rectangular prism. Now, the number of faces, vertices, and edges, being able to count these is important. So what you have to do is, again, kind of figure out a way to keep track. What I do is I just kind of mark them as I go. So this is 1, this is 2, this is 3, this is 4. And I have 4 over here. 1, 2, 3, 4. So that means so far I've got 4 plus 4 plus now the side ones. 1, 2, and I've already counted this one. I've already counted this one. So I only have 2 there, and I have 1, 2 over here. So that means 4 total here. So the total edges I have are 12. What about vertices? So vertices are where you have points. So let's do this in a different color. So we have points, and the vertices we have 1, 2, 3, 4, and back here 1, 2, 3, 4. So vertices, we have the front part has 4, we have the back part has 4, so the total number of vertices is 8. And last thing is the faces. So the faces, again, a way to count them. You have 1 here for the front face, 2 here for the side face. So you have the front and back, I should say. And then the third one is going to be your top. So you have third is top. 4th is bottom, 5th is the right side, 6th is the left side. So think of these, the faces, front, back, side, side, top, bottom. So in this case we have 6. And again, this is called a rectangular prism. Now for the next one, I'm going to go through the name of it, but what I want you to do is I want you to figure out the number of vertices, faces, and edges, and try and see if you can figure out the number for each one of those. So in terms of the name, since we all come to a single point, you have a polyhedron on the bottom, and the specific name for the polyhedron, we have 1, 2, 3, 4, 5, 6 sides. So it's a hexagon is the polygon that's on the bottom. And since each one of the vertices, it comes to a single point in the third dimension, we call it a pyramid. So this would be a hexagonal pyramid. If you had a square, it'd be called a square pyramid. If you had a triangle, it would be a triangular pyramid. If you had a pentagon, it would be a pentagonal pyramid, so on and so forth. So pause the video now and see if you can figure out the number of faces, vertices, and edges. Okay, so what you should have come up with is 7 faces, 7 vertices, and 12 edges. If you didn't, you might have to count again and see where you made your mistake. Okay, so it says tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. Well, this one, you can't tell it, or you can tell it is not a polyhedron because of the circle that's for the face. So this is actually a cone. It's a different type of three-dimensional figure. Okay, so we have tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. So I'm going to go through these kind of quickly. So the first one, I look and I see it has a square on the bottom, and it also, each one of the vertices has a line that comes to a single point in the third dimension. So that means it's a pyramid. All of the faces are polygons, so it is a polyhedron. Which means we have a square pyramid. And counting the number of edges, faces, and vertices, you would come up with 5 faces, 5 vertices, and 8 edges. Okay, for number 2, it has a curve, so it can't be a polyhedron in the front here. That's what makes it not a polyhedron. Okay, for the third one, we know that it's actually going to be a triangular prism, and the reason it's a triangular prism is because we have each one of the faces here is a rectangle, and the front and the back, or top and bottom depending how you look at it, number 1 and number 2, front and the back, those are triangles. So that means it would be a triangular prism, because in the third dimension it extends out as with rectangles. So this is a polyhedron. It doesn't have anything that's bounded by curves, so it makes it a polyhedron. The number of faces, vertices, and edges would be 5 faces, 6 vertices, and 9 edges. If you're noticing you're getting these wrong, you need to either ask me or double check and see how your counting is, or what you're counting. Okay, so one of the reasons why I was making you do all finding the vertices, edges, and faces is because we have something that's called Euler's formula, and this occurs in all polyhedron. So what Euler's formula basically it takes the number of faces, the vertices, and the edges, and there is a common theme between them. If you added the vertices and the faces, like here, added the vertices and the faces, that would be equal to the edges plus 2. This 2 constant just occurred in nature when dealing with a polyhedron. So this is the formula you need to commit to memories, because you're going to see this in some of your module quizzes. And I'll be using this throughout the examples. Okay, so we have this figure here, which is a rectangular prism. The number of faces, you have your top, you have your bottom, which is here. You have your side, you have another side, which is here. You have your front, and then you have your back, which is back here. So you have 6 faces. Okay, vertices, we have 1, 2, 3, 4, 5, 6, 7, and then you have to imagine the one back here, 8. That's if you drew the imaginary part here to make the third dimension. Okay, for the edges, we have 1, 2, 3, 4 for the front. 1, 2, 3, 4 for the back. And then don't overcount or double count. You have 1, 2 here, and then 1, 2 here. When you add those up, you get 12. When you plug it into Euler's formula, that gives you 14 equals 14, which means that it's a polyhedron. It just proves that it's a polyhedron by this constant formula.